Video briefly shows how to start a cluster on Amazon and how to start a notebook to run Spark jobs interactively on this cluster. So this is done using the Elastic Map Reduce EMR service from Amazon. So going to the website and documentation, view all documentation. The EMR service is part of the analytics set of services here. And instructions to get started can be found in the management guide. So I encourage you to read this description of what EMR is about. And we'll mostly focus here on getting started, so which is how to launch a cluster and how to access it with a SSH, and how to create a notebook and how to interact with the cluster services and Spark using the notebook. In the getting started part, you have the prerequisites. So you need an AWS account. This part is to create storage spaces with S3. So we won't need that here, but we'll need EC2 key pair to SSH to the cluster. So to create a key pair, you go to the management console. And the key pair creation can be found in the EC2 service here in the network and security key pairs. So let's create a key pair and give the name AWS EMR. So this is downloaded on our machine. And we can look at, here now it's in download, there it is. So going back to the instructions, let us see how to launch a cluster. Connect to AWS, and now from the management console, let's go to EMR, which can be found in the analytics here, set of services, EMR. So these are clusters that I created before. Here the two main parts are this cluster tab, where we can create a cluster, and here the notebooks, where we'll be able to create a notebook later. So let's first create a cluster. Give it a name, say my EMR, and here you can decide which set of services you want to be running on the cluster. So it could be, say, Hadoop and Hive and Hue, or a combination of HBase, Hadoop, Hive, Hue. So here we'll look at this Spark configuration. So we'll have Spark and Hadoop, Yarn, Ganglia, which is good by default. If you want to have a more customized set of services, you can go to the advanced configuration and here pick those services you want to have running. So we can go back to the quick options, since this one is good for us. In terms of instance type, by default we have this M3 X large, but this is part of the previous generation of instances from Amazon, and we'll take one of the current one, which is now M5 X large. So you can have a look at the instances and the instance types page of Amazon. And so the one that we just chose is a general purpose machine here. This one with 4 CPUs and 16 gigabytes of RAM, which is good for us. Then you have other options you could choose from. So if you wanted to have GPUs, you go into this part and you'd have Tesla V100 GPUs on the machine. But let's stick with the general purpose one. To have an estimation of the pricing, there is this pricing page. There are two main types of pricing: on-demand and spot instances. On-demand are reserved instances, and spot instances are cheaper. You can bid for instances at different market prices, but we'll take the on-demand one, make sure that our instance keeps on running. And here the M5 X large is around 20 cents an hour. So back to the cluster configuration, let's start 3 nodes, so there will be 1 master and 2 core nodes. And we choose the key pair that we just created, AWS EMR, and create the cluster. It takes about 2-3 minutes to start the cluster. So this is the main page to have information about the cluster. So there would be a summary of the machines. Here in terms of hardware, 1 master, 2 cores, so it's now provisioning. We'll have this tab, Application History, where we'll have the Spark user interface of the Spark jobs that we are running on the cluster, and then different tools, monitoring, have an idea of the resources which are used on the cluster, so hardware, 1 master, 2 slaves, different events which are running. So now cluster is being created, and so on. So we can go to this notebooks page now, and so those are ones I had created before. Let's create a new one, and we can say give it a name, Spark. Here we can choose an existing cluster, so let's use the one that we just created, and we can leave the rest as it is. Okay, and now create a notebook. So before opening it, we'll need to wait for the cluster to be started. So now the master has been provisioned. We have here the URL to the master node of the cluster, and with these instructions here we can SSH to it. So it basically uses the key pair here that was downloaded previously, and the key pair is in my download folder, and I can SSH to the master node using the Hadoop user. And before doing that, you have to change the permission of the PEM file so that it's only readable by the user, so 400. Right, and now I'm connected to the master node of the cluster. I can have a look at, so I have my 16 gigabytes, and we can see that it's running different Hadoop services. I'm going back to the cluster page. So it's still starting the cluster, probably 1 or 2 minutes left. So let's see what we covered here. So we launched our cluster. We saw how to connect to it using SSH. So this we won't do, but I encourage you to give it a try. So it's how to run scripts, here in this case a Hive script on the cluster, and how to clean up resources. in terms of notebooks, so we created one, and let's go back. So now it's waiting, meaning that it can accept jobs. It's waiting for jobs. Okay, running, and waiting. So the cluster is up and running. Going to the notebook, we created our Spark notebook here. So let's open it. And now we have our notebook, which can interact with the cluster. So let's start by importing Spark. This takes about 15 seconds. Once this is done, it's going to tell me that Spark is available as the Spark variable. Spark session available as Spark. Oh, yeah, by Spark. And now let's get the Spark context. And let us define a function, wait 5 seconds, which basically just wait 5 seconds and returns what was provided as an input. So this is just for basic testing. So now let's create a list of 8 elements and let us parallelize the list into an RDD with 8 partitions. And a simple Spark job where we apply for each element of this RDD, wait 5 seconds and collect the results. So this should return the list of 8 elements from 1 to 8, from 0 to 7 that we created here in data. So running this, we have this nice interactive summary of what's going on. This is a small bug, so basically it worked. I'm not sure why we have that, but if we rerun the job, then it works fine. Okay, and if we go back to the cluster that we created, here in the application history, we can have access to the details of the Spark session. So that was the second collect that we just done. Okay, and now we see that so the job was parallelized on the cores that we have on the 2 executors. Finally, and very importantly, think of terminating the cluster after you used it, otherwise it will keep running and may give you bad surprises on the build.